All right, guys. Hey, I'm Rahul. I've been a web developer for about 5 years now, focusing mostly on Ruby on Rails applications, some front-end work like Angular, React, and lots of back-end work. At the same time, lots and lots of mobile application development on Android or semi-native applications, things like that. The headline for the talk is a little bit deceptive as it says Action Cable and Firebase, but it's more of like a way of optimizing business logic across your application and using the capabilities of Action Cable and Firebase for the ability to do that, to be able to do that. And my biggest pet peeve is that you always end up introducing a lot of business logic on the view layer of your application. So you have a ton of it on the model layer, you have a ton of it on the controller layer, but you also end up having a ton of it on the view layer. So that makes it a bit of a pain to manage throughout as well as maintain as you're going across with it, because you have to keep figuring out what somebody did to 3 different levels of the stack. So this was sort of my workaround to it. Generally, when you're using anything like live data or WebSockets, you have your general use cases. So you probably want to, so for this talk or for the application endpoint, once you get to it, what kind of applications you can use it with is, let's say if you're using your web app with something like Angular or React, this works out perfectly because React and Angular have state-based UIs. And if you pass in a model state, then it will basically render that UI. And why that works, I'll get to in like a second. Also, web applications requiring live data. So for example, if you want lots and lots of stock data which is live, you're scraping lots of web data and you're passing it through your application and you want to see it either on your phone, you want to see it on your screen or something like that. At the same time, if you're using your Ruby on Rails application with something to pass on data to, for example, a Android application or an iOS application, rather than have your application make network requests to your web app, what you can do is all actions make network requests, but the state of the view is being passed in back from either Firebase or from Action Cable or whichever way you choose. So again, the objective of the project was to propagate a live push across everything. So let's say you have an Android application, you have an iOS application, and you have a web application, all looking at like the same data. And what you want to do is once that data flips, you want to update all of those applications. All of this exists at the moment, and you can very easily do it. But the thing is, there's no unifying factor, or it's just like an abstraction on top of it. And the second pet peeve that I actually mentioned, that having lots and lots of business logic on the view layer of things, and you sort of want to move that out back to the model layer or the controller layer and not allow the view layer to, you basically want your view layer to only be rendering views, be in charge of user experience, and not actually be dependent on business logic. So when you go change something on the model layer, you don't want to break your UI and all those things. And at the same time, you want to play around with all the modern frameworks and all the cool toys that come along with it. The general frameworks or the libraries that we use are, so in Rails specifically, we use Active Record. Within Active Record, what we're using are callbacks. So callbacks are basically, well, actually we'll get to it in a second. Ruby concerns or mixins, which are basically class inheritance or extensions, and Action Cable, which was introduced in Rails 5.0, which is basically a framework for WebSockets. We use Firebase as an alternative to Action Cable, and we use Angular and React on the front end. So generally, as you go across the stack, that's what it looks like. So your first layer is Active Record, and callbacks specifically are generally very, very underused, especially on Rails. Like you generally have your validation callbacks, you have your after create callbacks, you have a bunch of like, basically those are the most 2 used ones, and we never actually get into using the rest of them. At least I haven't seen a lot of usage in my experience. So that's something which I wanted to plug into. The next thing that you need is action cable, which allows you to create like WebSockets. The advantage of WebSockets is twofold. The first one is it reduces a lot of overhead from network requests. So every network request has on average about 500 to 600 bytes of overhead. And let's say if you just want to do a state update of any model data, then you can just send in either the new state of the object or you can send in what changed. In this case, we're going to just send in the state, and it's not smart enough to figure out what the change was. So we use it for that. And the pub sub method, if you're familiar with it, then it's basically just a publish and subscribe method, which allows you to publish everything to a channel. So for example, we have 10 consumers subscribe to the price of, on Amazon, for example. So you've subscribed to the price of an item. So anytime the price of that item changes, you want to basically receive either a notification or you want to see it on your phone and all those things. So Amazon publishes the price of the item on a channel, and all your consumers would receive that price. Mixins are basically just a fancy word for inheriting or extending a class. They do have some sort of logic behind it, but generally that's basically what it is. Broadcasting and receiving, that's just the additional logic you add for every method that has an impact on an object. So let's saving, creating, updating, or deleting. Not exactly reading, but everything else. So you want to broadcast those changes. And receiving, so since you want your front end to do the least amount of work, you don't want your front end to make AJAX requests, and for each request expect a different form of response and allow the UI to behave in a different way. What you want to do is pass in a state, and that's it. So your UI only handles the state of the object. It triggers actions, and that flow will basically return a new state, and that's what you render. You don't wait for the request to come back. You don't put a loading spinner. You can if you want to, if you have like a large request or something, but you don't individually handle requests. You basically base your UI on a state which is returned by your controller. So all that logic that you were putting in for, the data got returned, I need to transform the data in a certain way and then display it in a certain way, and all those things are all handled back to the model or the controller layer. So just going a little bit more into the details, for active record and mixins, the general things that you need to implement something like this, you just need to plug into the callbacks of the active record model. So if you override the active record concerns, you can plug into all these functions and override them. And if you ever included the concern or the overridden class into your model, you would suddenly have like a super model which has the ability to save and then broadcast all its changes or its new state to whoever is actually subscribed to it. And propagation functions are basically either Firebase or send state. So for Firebase, what you do, Firebase is a live database. So if you actually sent a request to Firebase to update any field or any value, it will immediately update it for every other mobile application that it's watching. So for example, if you have your stock application open on your phone, you can save the change of the stock price in Firebase, and Firebase will propagate that change into your iOS application, your Android application, and so forth. They use WebSockets in their underlying layer as well, but Firebase is just like a very, very nice tool and a simple to use tool to do it. And it's very, very easy to plug in with Rails, and all you have to do is just initialize it, set a fairly, and just basically call it. It's quite literally 5 lines of code, and you need to work with none of the action cable stuff. Send state action cable. So that's where it gets interesting, where you want to implement action cable, start hosting it, and do all those things, and send the updated state of any object via the action cable WebSocket to whoever's subscribing to it. That's the active record part of things, and moving on to action cable and Firebase part of things. So let's say if you wanted to implement a Firebase one, you basically add an initializer to your Rails application, and you can call that initializer from everywhere. And you can call it from a controller or a model or a concern, and anytime a model is updated, you can have an interface method which gives you the name of the model, and you can appropriately update the column in your Firebase application. And on the other side of things, on the UI, you can have it pull or watch for those model changes. On Action Cable, you mount your web server. Again, you can do these like the basic. If you just Google Action Cable implementations, the first one will probably be the best one for it. The only change that you're doing is as soon as the application is launched, you want to subscribe to model changes or whatever you call that channel. So since you have a concern which is included in all your active record models, then that concern will broadcast that message across for every model change. It will broadcast that message on a model changed channel. So as soon as your application is launched in a web server, or let's say on a phone, you subscribe to that channel and go like, give me all the model changes. And as soon as the model changes start coming in, what you get is you get state of everything. You get a state of the user. So is the user logged in? What's the user's name? What's the user's profile picture? You get a list of items in the user's bucket, and all of them are basically different states of the different objects which are in your database. Or if you're using scoping, then you can even have states for specific views. So you have your same models with different scopes, and they will pass in new states as they get updated. And that basically closes the loop. Actually, to close the loop, you need one final piece. So front-end considerations. Frameworks like React and Angular are state-based. So if the state of an object changes, your UI will update. And what you want to do is it's already being used. We always do that when you make a network request, when the results come back, what you do is you parse the data and you update the state. That's exactly what you're doing on your UI end. The part that's actually being removed in this process is the response of the thing. So rather than create a state in your controller.js, for example, in Angular, you're passing in that state from Ruby by itself. And Action Cable will just return that state for an object rather than you having to figure out what that state should be in your UI layer. And it seems almost a completely closed loop for Angular-based or React-based applications. So anytime you perform an action, it performs a network request, but it never expects a response back. So you're just triggering a request and you're forgetting about it. The request gets triggered, and after all the changes are made, something will get broadcasted to the channel, and that something is the new state of an object. And once that state comes in, your UI re-renders automatically, and you worry about none of the other things in between. So when you're actually creating your UI, all you have to do is implement your UI for this one state that that Action Cable is returning, versus every action, versus every sort of interaction. And even your interactions can be ported over. So your state can return a list of actions that can be performed on an object. So when you're actually doing all of those things, rather than parse them out, call them back, figure out which to map to what, you just call them and your controller takes care of everything. So you can pass in the control, your controller will check if the action is valid, your controller will figure out what to do with the action. Once it's finished with the action, your controller will go like, yo, here's your new state. And that sort of closes the loop on the entire circle. And it becomes an event-based sort of model versus a network request based. That you send a network request, you're waiting for it, or you do something like that. I understand it's not possible in all cases, and that's why there will be some sort of considerations that have to be made. But just for like simpler applications, it's a very simple loop that's completely action-based, and you never have to wait for anything. That's basically the gist of the idea. I've started doing this for a project of my own, and so far it's worked very well. The problem with the project was, as mentioned, that there was a ton of business logic on the UI end, and there was a ton of business logic on the model end. And I basically just removed it, moved it over, and did this sort of thing. Yeah, questions and suggestions.
So how do you deal with sort of managing access? So anything involving authorization?
So every time your WebSocket connection is created, you have your user information goes by default via it. And since your user information goes by it, you automatically figure out what level of access you have for each object. And Rails again does this like before action or before controller. You always do this. So even when you're sending a network request, it's still being used as the same bearer token. So the data you get is authenticated as well as the actions you're sending are authenticated too.
Okay, and it's JSON web tokens, that's the mechanism?
Does it store any previous data that was input into? Like if you want to reference back what it was before, or you made a mistake in doing something that you want to change back?
No, you won't. You won't be able to do, there's no history of data. Like once your state changes, your state changes. And there's nothing from the previous history into it. Yeah.
At the beginning of your talk, you mentioned that you were using both React and Angular on the front end. Is that right?
A little bit of React and a ton of Angular, yes.
So it's very unusual architectural decision, though I have seen it before. What is the rationale behind it? Why would you say you would use Angular for this piece and React for that piece? What is the decision? How is the decision made?
I personally like Angular a little bit better because of the two-way data binding. React by itself has one-way data binding, and you need to figure out how to do the whole Redux part of the structure at the same time, figure out all the practices. It becomes a different beast by itself.
So then why use it at all?
Why use it at all? If you're honestly, I don't have an answer for that, but people who actually understand React or in depth do actually have a rationale behind it. And I have worked with it before, and I do work with it, so I do understand the idea behind the whole React and Redux thing. It's trying to mimic, not trying to, it does mimic a lot of the stuff that you do on the MVC part in your backend. And basically smart views, right? That's what they are. They're really, really smart views. And you're basically abstracting knowledge, your context away from the backend towards your front end. And for that, you need stronger tools. So Angular, you probably need something like Node.js with it, and a ton of controllers. For React, there's Redux. And there's the circular flow of data that it creates within React and Redux. So I'm assuming so if you're using it with Node, then you probably want to go with React and Redux versus just Angular if you have a larger application. But somebody else would probably have a way better answer than that.
So Angular generally is much stronger with state management out of the box versus like React. React has no opinions about how to manage state. So that's why you use Redux, right? But sometimes you don't want to use Redux. Yeah, we'll check that. Yeah.
Any other questions, suggestions? Yeah.
So this is maybe a bit of an aside, but I'm curious with, you gave an example of like updating like the dollar amount of an item or something like that. And then the clients will receive that update. Is there a way to also ship like background notifications or have like a background task running on a native iOS app, for example, to pick up changes from Firebase, or does the app have to be like running in the foreground?
I believe it's the WebSocket implementation, and the WebSocket implementation follows the general rule. The WebSocket is suspended until some data ping comes through it. So that's a way to manage like tons and tons of WebSockets with a limited number of threads. So I'm assuming iOS and Android do the same things, because you can see the same things on Rails, Nginx, and all of those things. So it will have, once the application is launched, it will have a WebSocket connection. So as soon as the application comes into the foreground, it will ping that WebSocket. So even though for push notifications by themselves, there is a separate methodology. Again, triggered by the callback hooks, but it follows the Android notification methodology if you want to see a notification. If you just want to see live data the next time it comes in foreground, WebSockets handle that like out of the box. Yeah.